Okay, hi, welcome. This is Motsi. It is my pleasure, and it will always be my pleasure to have you around. Today, we are going to be exploring factorization of quadratic expressions. Of course, this will be part two of the factorization series we have been having. These will be the questions we shall use to explore this concept. Let me make this disclaimer one more time. This is no level specific, whether you want a refresher, you're new to algebra, or you've been in algebra for some time, this should cover all of you. However, if you want something that is specific, do let me know in the comment section. But if you want it so urgent, I have a Preply account. You can reach out. I'll leave the link either in the comment section or in the description box. Otherwise, let's go. First question, we have x squared plus 7x plus 10, and our assignment is to factorize this expression. This indeed is a quadratic expression, and how do we know? Well, as we check the highest power of x, it is 2, and that means it's a quadratic, because quadratic have a standard general structure, which is ax squared plus bx plus c, and since this is from this family, it means that's a quadratic. Now, the method we shall use to factorize this is called grouping, and this gives this expression a very unique property in the sense that there is a relationship between the product of these two and this middle term. If you multiply this term and this term, which is this highest power of x and this lowest power of x, we get 10x squared. And this 10x squared is related to this 7x. How? Good question. Well, it turns out that there is a unique pair of factors of this one that add to this middle term. As we are beginning, we shall list all the factors of 10x squared, but with time, as you do these problems over and over, you develop the intuition to just figure out those two factors even without listing all of them down. Let's list them. We have 1x and 10x, and of course these two multiply to 10x squared. We can also have 2x and 5x. These also multiply to 10x squared, and we have negative 1x and 10x, of course negative 10x. They also multiply to 10x squared, and we also have negative 2x and negative 5x. They still do multiply to 10x squared. And it turns out that of all these pairs, there is a unique pair that do add to 7x. And this is the pair that we're going to pick and go through these and to choose which one. I hope you picked this one, and if you did, very good. So these are the factors of 10x squared that add to 7x. And factorization by grouping utilize these because instead of writing 7x, we write it in terms of these. So I'm going to have x squared plus 2x plus 5x plus 10. Notice I have not changed this expression. What I've only done is, instead of writing 7x, I wrote it in terms of 2x plus 5x, which is still 7x. So I've not changed the value of the expression. I just changed the way in which I was writing the expression. Let's go ahead and simplify. Well, grouping means we're going to group these and make a pair here and a pair there. And we're going to factorize this part and let factorize that part. So let's factorize. What's the highest common there? that's x, and of course x into x squared, that's x, and x into 2x, that's going to be 2. And of course plus is already out. The common here is 5. I take it out. 5 into 5x, x is going to remain 5 into 10. Of course, I still have a 2. And now I have two terms, this one and this one, and I'm going to factorize. Now I'll give you a clue. Anytime you're doing a problem like this that you're factorizing and you see these that are the same, you know that you've gotten it okay. Otherwise, if it was not the case, these ones would have not been correct, or they would not have been the same. It would have meant that your factors that you chose had at least something that was wrong about them. Otherwise, let's go ahead and let's factorize. So what is common here, if you recall from the previous video, we learned that this is common right here, so I'm going to take it out. So that will be x plus 2. I'm taking it out, and this is going to leave me with x, and this and that will leave me with just a 5, and this becomes our final answer. Of course, you can try and prove that to see if indeed when you multiply it out, it will give you that. It's quite easy, you can. Let's do it together. So I'm going to break this, and then x plus 2. Let me just break it on the go. X plus 2, and rewrite that. That will be x plus 5, and x plus 5. X times x, that's x squared, and x times 5, that's 5x. 2 times x, that's 2x, and 2 times 5, that's a 10. And of course, x squared is no term like it, but this gives us a 7x, and of course, plus a 10, which this and this are the same, which means the answer is correct. So anytime you doubt your answer, you can easily prove. Hope it makes sense to you. If you feel confident now, you might pause the video, give this one a try, and see if you get it okay. Otherwise, if you're not that confident, you might as well relax. We'll do one more example again. Let's get rid of this one. Okay, the next question, we have x squared minus 24x plus 144. And our assignment is to go ahead and factorize this expression. Of course, it is a quadratic. How do we know? The highest power of x there is 2. And it means if we multiply these 2, which gives us 144 x squared, it turns out that there is a relationship between this and that. And what did we say is the relationship? That's right. There is a unique pair of this that add to that. And of course, I'm not going to go ahead and list all of them, but if you want, you can. We can see that it is negative 12x and negative 12x. If you multiply these, they will give us positive 144x squared. And of course, if you add these, they do give us 24x. Therefore, instead of me writing negative 24x, I'll write it in terms of these. That means I have x squared minus 12x minus 12x plus 144. Now that I have these four terms, I can group and have these pairs. Sorry about that. And I can factorize this one on its own. What is the common there? Of course, it's x, and x into that, that's going to be x. X into that, negative 12. Minus is already out. Common there is 12, and of course, x is going to remain, and negative 12 into positive 144 is negative 12 again. And I'm going to factorize. This is common. I'm going to take it out. And of course, I'm going to have x remaining. And of course, I'm going to have negative 12 remain. Of course, this is called a perfect square. It's called a perfect square. It means this expression was actually a perfect square. And we can write this as x minus 12 squared, which just means this in other words. I hope if you tried it by yourself, you've been able to get an answer that is close to that one. Otherwise, if not, you can just look at where you got it wrong. But if you're confident now that you can try the next one, you might pause the video, give it a try. Otherwise, let's move on. Okay, next question. We have a squared minus 2ab minus 15b squared. And that is our next question. And our assignment still remains the same. We are to factorize that. Same process. I'm going to multiply this 2 since it's a quadratic. See that by having a square right there. And that's going to be 15. Actually, that's going to be negative 15 a squared b squared. A squared times negative 15 b squared will give us negative a squared b squared. Now we're going to look for the factors of negative 15a squared b squared that do add to 2ab, actually to negative 2ab. And what are those? Well, you might list them if you're still not so sure which ones they are. But from the look of things, it turns out that it has to be negative 5ab and positive 3ab. So a technique, let's say you are still struggling to get these factors, especially if it is a negative here and here it's also a negative. First of all, what we can understand is if we want to get a negative product, it means that one of our factors is to be a positive and the other one is to be a negative. Otherwise, if they are all negatives, we'll get this to be a positive. So rule of thumb, if it's a negative here, it means that you need two factors that are opposite, the other ones being a positive, then the other one being a negative. And that's what we try to do here, positive and negative. Secondly, you want your bigger factor to carry the sign that is carried here. This is going to be a negative, so definitely you're going to give 5ab the negative sign, so that when you do the addition, your answer will still remain as a negative. Otherwise, that's just the trick that will help you easily see which one you give a negative and which one you give a positive. Let's go ahead. Instead of writing this, we'll write it in terms of these vectors. So that will be a squared minus 5ab plus 3ab minus 15b squared. Now we notice that we have substituted this with that, and we can easily group now. And what's the highest common there? That's a. We take a out, a into that. That's going to be a into that. That's going to be negative 5b plus is already out. I take it like that. And what's common there? It's going to be 3, of course, and a b. I take it out and 3b into that. You realize that a is going to remain, and 3b into that is going to be, of course, a negative, because positive and negative, it's a negative, and that should be able to give me a 5b. And once you see that these are the same, you should be happy, because it means you're in the right direction. We go ahead and factorize. This is common, so I'm going to take it out. That's a minus 5b. And of course, this that I'm going to remain with a, and this that I'm going to remain with 3b. Hopefully, you've been able to get something like this if you had given a try by yourself. Otherwise, ladies and gentlemen, this is factorization of quadratic expressions. Quite an interesting something to do. I hope you've been able to get value from this video. If you did, make sure you click that like button, and if you have a friend you think that they might also benefit from this material, don't hesitate to share the link of this video with them. And if this community is making you feel good and adding value in your academic life, please don't forget to smash that like and that subscribe button. Otherwise, I should be able to see you in the next one.